Our first speaker today is Colonel Anurag Awasthi. Now, Colonel Awasthi is an accomplished veteran in policy formation, government affairs, and international collaborations with a focus on Make in India. And currently, he's the Vice President of the India Electronics and Semiconductors Association, and he's held various leadership roles even at the United Nations. If digital is a part of your business, it's important that we pay attention to what he has to say, because his talk today is going to have serious ramifications over the next decade and into the future. Colonel Awasthi, over to you.
A very good evening, ladies and gentlemen. I'm Anurag Awasthi, and thank you very much, WMG, for having me here and to tell you more about semiconductors, the buzzword as we speak all over the world today as to what is happening insofar as these ubiquitous chips are concerned, which are now powering everything from safety razors to space shuttles. So I will not bore you with a lot of technical jargon. I will not get into MWPs and nanometers and all of that. But I'll try to keep it simple to make you essentially understand what is the major importance of these great chips that we are talking about. How are they made? Since it is the most complex endeavor known to man. It looks very simple that you have a small chip and it's powering your phone and it's powering your aircraft or what have you. But the endeavor is the most complex endeavor known to man. So I'll give you a small expose on that. Thereafter, I'll come down to whatever is to be done here, what is being done here. So in the next around 40 minutes or 45 minutes, I will first explain to you and give you a small little introduction. Then I would tell you as to what exactly are the global drivers of change. What are the exact global drivers of change? Because you need to understand there are a lot of drivers of change. Thereafter, I'll give you what are the ecosystem enablers and accelerators. What exactly are they? I will tell you what is technology and geopolitics. A lot of people say that technology and politics are separate. No, they're not. They're two sides of the same coin. We like it or we don't like it. That's the way it goes. Then the chip essentials and the troika as to what exactly, I will break it down for you for the want of time. Then of course I'll give you the opportunity canvas as to where India stands, where Bharat is going to be going, and what is the Indian snapshot. And of course thereafter, what are the policy metrics beyond technology that we need to understand as leaders, as important public and private sector players. All right, just look at this. Global drivers of change. The first one, global power competition, nothing to be said beyond that. Demographic pressure, just look at the issues of people moving in from rural areas to urban areas. All over the world, it's a phenomenon. Climate change, I don't need to dwell more on that. Economic transformation, energy transition, connectivity and the age of tech giants. We've all seen what's happened to Google. There's a lawsuit happening around in the United States. These tech giants are essentially running governments. They are running systems. They are behemoths. Their economy of scales are much better and bigger than most countries. Urbanization, internet, of course, environment with renewable energy, extreme weather migrations, which we're all seeing all over the world. Space is getting a little cluttered. There's space debris, which is going to be taking place very soon. And of course, there's water. As I always said, while I was in the uniform also, and I still maintain and believe as a very personal thought that most wars in the world are going to be fought over water. Water is very, very important. And then of course, all of them are technology driven. There are critical technologies, there's knowledge sharing and premium of skilled manpower. We've seen what happened during COVID. Cybersecurity, materials control, very, very important. We are seeing it all over the world. People need to control material now. Cartels, for a want of a more polite word. Supply chains, price hegemony, and weaponization of things which are smaller and not easily accessible to all. These are the global drivers of change. This is reality. That's the way it goes. So then there are some ecosystem enablers and accelerators. Energy, whichever way you call it. Water, regional affiliations. Whom are you with? Are you here? Are you there? Are you not there? Whichever way. Infrastructure and workforce. Now all of these 5 major system enablers hinge on policy making. It's very important. So I'm trying to break this whole complex system down for you to understand that, look, these are the 5 major ecosystem enablers and accelerators, and all of them are on pragmatic policy making. Why? Because it caters to leadership. It caters to a business case. It caters to domestic innovation and incubation, talent, financing consistency. We've just had 2 bankers speaking some great things. Security and trust, ESG, which has suddenly come in now, sustainability as they call it. And of course, the most important part, which we all know, demand. If it's not there, then it doesn't make sense. Moving on to this, you look at how the ecosystem enablers are, and then you look at the entire security infrastructure all over the world. All weapon systems. Core of all weapon systems, radio frequency integrated circuits, monolithic microwave integrated circuits, field programmable gate arrays, drones, AI and ML, quantum computing, surveillance, communication, missiles, IoT, robotics, supercomputing, space, specialist vehicles, all of them function on these chips. Therefore, there is something called technological interdependence of countries, because nobody is making this or utilizing this or getting into this endeavor end to end. It's segmented. Thereby, there is a technological interdependence of all countries. Having said that, just look at this small little chart, just to give you a small idea of the most complex endeavor known to man. You have a customer application idea in one vector, you have the SOC development, you put in EDA tools, which are most costly software available in the world, you have a pre-silicon validation, and there's a design layout. There's a design with miles and miles of transistors and cables into a small little micrometer. And then on the other vector, you make a silicon ingot from sand, you make a wafer, you make a fabricated wafer, you put that design on that fabricated wafer, you test it, you dice it, you package it, you again test it, you put it in the product assembly, and there you go, it goes into your phone. It goes into the air conditioner, it goes into your fan, it goes into your washing machine, what have you. Just look at this. This entire procedure takes months, if not years. So as I mentioned to you, this is one of the most complex endeavors known to man. So what happens because of this? There is something called the silicon chessboard. So how do you make all this? Obviously, you need equipment to make all this. Bulk of this equipment is made in the United States. Some part in Japan. Some part in Korea. And of course, the lithographic machines and the high-end lithographic machines all centered in the Netherlands. Then you come down to where the fabs are, where the fabrication facilities of the world are, all in Southeast Asia, Taiwan, Korea, Japan, some part in Malaysia, Singapore. And then you say, where are the packaging? That's all China. And then you say, what's happening in the world? There is the Gaza conundrum, and of course there is Ukraine, which is happening since the 22nd of February 2022, 2 years and running, if that's the date. And of course, all this is in post-COVID era, where most of the supply chains have been stretched. Look at the recipe. This is the digital chessboard. Now, in addition to all this, what you saw on this last slide, there are more than 150 chemicals and gases used for this process. Most of them pyrotoxic. Most of them have issues of cartage, issues of movement, issues of storage, issues of distribution, issues of destruction, and so many other things. Just look at this entire chessboard. That's the way the world looks like. And thereby, technology and semiconductors becomes geopolitics, because nobody is doing this end to end. Too many players. This is just a small little snapshot to tell you where the wafer factories are. Of course, I'm so happy that the first one is going to be coming up here very soon in Dholera. Very proud of that. The Tatas has already started construction and doing the work, whatever is to be done, since the 13th of March this year. Now let me break this entire story down into the troika. There's a troika for semiconductors when you look at it. A, equipment, which I just mentioned to you, which is used in fabs, and ATMPs are essentially where you do the packaging. Then you have materials, which are the chemicals, gases, minerals, etc., which are used in the manufacturing process. And then, of course, you have the services across the supply chains. So these are the main three elements, the trident for which these ubiquitous chips are made and prepared all over the world. Coming down to equipment, most important players in the manufacturing system, they supply all integrated solutions. Most of them are centered around the United States. Some in Japan, as I mentioned to you, some, a little bit in Korea. And of course, there's hegemony, as I mentioned to you, about the lithographic machines, etc., which are there in the Netherlands. Now, because of this, if you have this as the bulk, you also own a lot of IPs. No points of guessing, nearly 80% of IPs are in the Western world. So how do you break this chain? That is the whole idea. While the leading firms have a lot of presence in India, most of them in Bengaluru here, we all know that. But then at the end of the day, do we also become a part of the bigger ecosystem? That is the question. There are some R&D labs which are being done here by a lot of important players, world players, which is an outstanding job that they're doing. And of course, MSMEs in India, the way they're growing, they are ideal to and suitable to partner with all these people. Coming down to the materials, I wonder if you remember Deng Xiaoping in 1987. Deng Xiaoping said, and I quote, "If Middle East has oil, China has rare earths." He said it. It's a reality. So while China may be endowed with nearly 62% of the rare earths all over the world, the productionization capability of China today is at 90%. We've been singularly lucky in the last around 2 or 3 years. There are some finds of rare earths in Andhra Pradesh. Of course, we've got some lithium in J&K. We all know that. But then there are some security concerns and various other associated concerns with this, is how we process it. There are ways of processing these rare earths which will take a little time. So these are all gaps which policy, the government and all the industry is grappling with as we speak today. Of course, there are indigenization aspects which the government of India is looking very, very astutely into, and a lot of indigenization will take place in the next around 4 to 5 years. Truth be told, the Indian chemical industry is the 6th largest in the world. Contributes to nearly 8% of the national GDP. That's a huge pie, 8%. But the whole idea at hand is, how do we transition this from parts per million to parts per billion to get into the semiconductor grade manufacturing? Why we didn't do it earlier is because there was no business case. Now there is. So if that be the case, a lot of things are now falling into place. These are the chemicals. You just see the kind of chemical chains all over the world. But there is another case to this. And then there are gases. Now the problem is, a lot of people don't understand. A lot of people say, why don't you make a fab here? And why don't you make a fab there? And why is he going to Gujarat? And why is he not going here? And why can't you make a fab in the hinterland? And so on and so forth. This is the reason. Chemicals and gases, most of them cannot be transported by air. They need ports. So when you have ports, you need handling, you need training, you need cartage, you need storage, cryogenic containers, and thereafter, and so on and so forth. It's very complex. So how do you make something in the hinterland which doesn't have a port? So obviously, whatever will come out in the hinterland will essentially be the packaging facilities and the other ancillaries, and not the fabrication facilities. I will come down straight to the services, which essentially are the dicing, packaging, bonding, as I showed to you. There are fab services, equipment services, and supply chain services. There is a large talent pool of this available in India, a large talent pool. And with a lot of things like the Gati Shakti, a lot of things like the skill development, a lot of things like Digital India program, and various other things like Startup India, the government of India is doing a lot in this. So the job has started, it's well begun, it's on an upward roll, it's on a great trajectory. Let's see how it works out. Now let's come to the main part of the system. What is the Indian semiconductor opportunity? Now this is what we need to understand very clearly, and I would implore upon most of you, when you speak into public forums and speak with various other people, you must give them the India story. The first part is you're a market. You like it or you don't like it. You're a market, you're a large market. The Indian semiconductor market, as per the last report that we made, is going to be $100 billion by 2030. 100 billion. Only the semiconductors market. I'm not even looking at the electronics part of it. We know how we consume electronics. We are in love with electronics as Indians. The second part is young population. As we speak today in 2023, our median age is 28 years and 4 months, the youngest in the world. China is 11 years elder to us in the average. Till 2040, you have this demographic dividend. So what comes with 28 years and 4 months? At 28 years and 4 months comes aspirations. I like a smartphone, great phone. I like a smart car. I want to wear good clothes. I need to have a great wearable watch which gets me whatever I want to, so on and so forth. With these aspirations, demand is driven. So thereby, you will always have this till 2040. Yes, now what happens? The flip side of the whole thing is, how do you create jobs? At 28 years, 4 months, you can't let go of this opportunity. That's the demographic dividend God has given us in this great country. Talent. 1.5 million engineers every year. 8,861 engineering colleges. 6,600 private, if my metrics are correct, and more than 2,000 government. 8,800 engineering colleges, 1.5 million engineers. But then there was a little lax behavior insofar as electronics engineering was concerned. Electrical, microelectronics. Why? Because everybody, including me, when my child came to me, when it was time for him to do his engineering, when he wanted to, he asked me which engineering would I do, and guess what I told him? There you go, computer science. Why? Because there's ROI, return on investment. Google's, Microsoft's. So there's a boy who does electronics engineering, gets placed at 3 lakhs per annum, and there's another boy who gets placed at 12 at 22 years. Young population, demographics, all linked. But now things are changing. There was a time 3 years ago, there were seats of electronics and electrical engineering going waste. Nobody was taking them. That's not the case now. So things have changed. Semicon design potential. You're sitting in the cauldron of the semicon design potential of the world. Bengaluru. 20% of the world's designers come from India. But do you have the IP? No. That is the problem. What is the money spinner? The IP. What is the jugular vein? Is the IP. That is what is going to change now with the government policies when I come to you later. Engineering and manufacturing capabilities. See, what we did around in the last 30, 40 years is that unfortunately or fortunately or whatever the case may be, we got a little devoid of the industrial revolution. We did not form part of the industrial revolution. So be that as it may, we embraced the servicing sector or the services sector very, very vehemently. So out of the three sectors, the agri, the manufacturing and the service sector, the manufacturing sector for some strange reason got left behind. Why service sector? Because it was a low hanging fruit. It was easier. You had more manpower, more jobs were created. The systems were different. You opened your economy much late in 1991. I hope 1991? Yeah, 1991. So somewhere down the line, we somehow missed the manufacturing opportunity. That's getting changed now. Aggressive government policies. The Indian semiconductor mission was launched in the December of 2021. Post various stakeholder consultations, the policy was tweaked in the October of 2022. You have a production linked incentive which looks at the fabrication facilities for the chips as well as for the display units. I mean just look at the extent of display. I mean, you go into one Vande Bharat ever. You see the amount of display there. Just look at the market you have. One small wagon has all display and display and display. Whatever you do is display, from your watch to your phone to your TV to this, everything is display. The PLI looks at this. Then there's a design linked incentive, which the government is now putting in a lot of money to the design entities, the fabless entities, to nurture them, to support them, to give them the requisite funding to somehow reach a particular level so that there is product which comes out of it, not research paper, product. Nothing against the academicians, product, not a research paper. And then you have something called the chips to startup. So you're looking at startups and academic institutions who cannot buy EDA tools. If you go back to my previous slide, you saw that EDA tools to make the entire system design. Each EDA tool or a purposeful EDA tool costs you nearly 3 to 5 crores for a year. How does a startup afford that? So the government is pitching in that money, whether it is an academic form or a commercial form, insofar as the EDA tools are concerned in the chips to startup. And then of course you have various schemes on PhD and this, that and the other. So all the bases insofar as this aggressive policy making by the government is concerned are now completely covered. And of course you have two great neighbors. One sits up north. There's a guy who sits up west. I love both of them. I fought both of them. And so many others. So there are geopolitical aspects, as I mentioned to you. So everything, as I mentioned to you, in technology finally hinges on to geopolitics. Right. So this is the Indian canvas of the semiconductor opportunity. Market, just look at the market by 2030. This is estimated. 100 billion, as I mentioned to you. Bulk of this is handsets. Automotive. You're the third largest automotive market in the world. Just look at the scales that you're working on. And you see, you can't predict technology. A lot of people keep telling me and asking me, how do you predict? How is it going to happen in 2028? People are very kicked. They keep asking me. So I tell them, go back to Bengaluru. See that great picture that you see of Texas Instruments, the first machine coming by a bullock cart, 1985. Did you know that you will be the home to 20% designers in the world? No. I belong to a generation where there were two cars on the road. Herald, standard Herald, of course sir, thank you. Oh yeah, that was a great one. That engine used to open like that in a very strange manner. So when Maruti Suzuki came into being in the early 80s, it was a game changer. Lo and behold, today, you're making Mercedes, you're making Audi, you're making even Land Rovers, you're making so many other great cars in the world today. But has Maruti lost the market? No, it's still 40% and above. So anybody who says how the technology, how the cookie is going to crumble, you don't know. It's all pervasive. So you can't predict how it is going to be, but this is how it looks like. So in the opportunity canvas, we are looking at this potential opportunity insofar as India is concerned. By 2030, 85 to 100 billion dollars is what we are looking at. When you're looking at equipment, as I mentioned to you in Troika, we are looking at around 15 to 18% of the world pie. In materials, we may look at 10 to 12% of the world pie. And in services that we are past masters at, we are looking at around 20 to 22%. This is how it stands as per various calculations, various metrics, various inputs, various ideations, so on and so forth. But this is all pervasive. How the cookie crumbles, we would know. Now look at this talent powerhouse of the world. I just showed that slide yesterday in the India-US working group, yesterday in Delhi in Sushma Swaraj Bhavan. And I could see a lot of my contemporaries from the other side of the Atlantic and see their mandibles drop. Just look at this. This is talent. How do you harness it? You are going to be the talent powerhouse of the world. And how do you need to harness this? By inculcating various things, which the government has already done. In 2023, February, AICTE has put VLSI as a part of the curriculums. There are private and public universities now which run BTech into VLSI. Faculty development programs have begun. There are old veterans from the industry who will be now taken as professors of practice. So all these things, all these gaps are getting slowly and slowly mitigated. Slowly and slowly mitigated. Just look at this. I mean, there are numbers which look like populations of some countries. Right? So where is the India snapshot? Where are we? Where are the strengths? You have a robust chemical industry. That's a strength. Steady talent flow, if calibrated correctly. Access to full design cycle. You are sitting in the as I told you, cornucopia of the full design cycle. Robust policy framework. Availability of infrastructure for component manufacturing. Massive MSMEs. MSMEs are the backbone of this country. All of us must understand that today's startup will be tomorrow's MSMEs. Tomorrow's MSMEs will be large corporations. Unfortunately, we have not started thinking like empires. We need to think like empires. How is it that China has got more than 200 corporations and you are struggling with 12, 13, 15? We need to think big. Thinking is everything. So most of these countries, when you look and I speak with them, somewhere down the line, I always get this feeling that these people think like empires. Somewhere down the line, we will need to change the DNA of our guys, the new generation, to make them think bigger, even more bigger, so that they embrace this thought. Then, of course, there are opportunities. Most of the CEOs and CXOs of semiconductor industries and global CEOs are all Indians. We all know it. So there's Indian diaspora, which is there. There's volatile geopolitical landscape. Of course, it's an opportunity. Emerging technologies, you're doing a lot of good work in emerging technologies. So this remains demand, of course, and of course, international collaborations. We've just seen in the last around 5-6 months, we inked the MOU with Japan, we inked the MOU with EU, we inked the MOU with Singapore last month. So there are a lot of international collaborations which are going to be happening. And either which way, anybody who says that, this famous talent deficit is an Indian phenomena is wrong. Talent deficit is a global phenomena. It is a problem. And then, of course, you have the issues of hardware and software. We all have children. It's a millennial thing. At the end of the day, there's a small young boy or a girl who's clickety-clacking onto the computer, and if you ask him or her, what are you doing? She says, I'm speaking with my team in Paris, I'm speaking with my team in Taipei, and oh, I'm on a call with somebody in Seoul. How fancy is that? But in hardware, oh dear, you have to get up, wear that famous suit, possibly have breakfast in the morning and go. That's a problem. Think about it. And then when you look at the curriculum of the electronics and the electricals and all these microelectricals and associated VLSI, oh, it's a tough course. It's not as simple as it looks. So there are issues, cultural issues also at hand. And then there are weaknesses. You have to speak about weaknesses. There's low linkage with fabs. We do not have fabs. The first one is coming up. So till you have linkages with fabs, how do you go on with systems? This is being now mitigated by the National Science Fund and the National Research Fund. There's a very weak R&D focus in this country. It is a fact. And a lot of people keep speaking and telling me, oh, we have the brains and all of that. I wonder why are we not doing this and that and whatever. But please understand, ladies and gentlemen, R&D is not a function of your cerebral acumen. It is not. It's a function of money. That's it. That money gives you that leeway to fail and succeed and fail again and succeed again and fail yet again. This part is a weak focus in this country, which is now being mitigated slowly. Faculty development, I already mentioned to you. IP, I just mentioned to, and the last part is talent management. There are people like me who do a particular course and take UPSC exams. There are people who go to great engineering schools and go into civil services, bulk of them. There are great people who go into various other schools and join something else. So that talent development needs to be a little pruned. And a lot of people speak a lot about tier 1 and tier 2 and tier 3 cities. Somehow I am a little averse to this tier 2 and tier 3. What is tier 2 and tier 3? We are creating problems in our mind which don't exist. When Tata went to Jamshedpur, did he think it was tier 2 and tier 3? We just saw Ratan Tata. When Reliance went to Jamnagar, did he think Jamnagar was some tier 2 or tier 3 or tier 4? No. So we need to nurture the talent in these smaller towns and smaller cities. And ISRO is a live example, ladies and gentlemen, in front of you. Bulk of its talent comes from here. It's a success story of the world. So this is the India snapshot. But then there are some policy metrics beyond technology. Soft skills. I was in BITS Pilani some 3 months ago, and I was standing there with the dean, and I told him that, we just stand in a corner in some place and just see, or whatever it is. With another faculty, I was just standing. And I told the faculty, I said, look, in the last around 4-5 minutes, there's a bulk of people who have passed by. Tell me how many of them were wearing laced shoes? Very less. So while I don't say that soft skills are very important, but soft skills need to be inculcated. This is my personal observation. And we really need to look at this. Millennial dilemma, I've already mentioned to you. Create buzz, awareness, change syllabi at all levels. This syllabi at all levels also looks at all 4 tiers. The base of the pyramid, technicians, operators, the undergrads, the grads, and the postdoctoral. So all these 4 tiers need to be addressed, which are being addressed slowly and steadily. But bulk, when I speak with most of the international embassies and various other countries, when I speak with them, the demand which is going to be coming in the world is going to be these technicians and operators, the bottom base of the pyramid, the largest base. And guess how many ITIs we have? 12,000 plus. Just look at the landscape and canvas. And now a lot of fire and emphasis is being moved into them. Augment startup ecosystem further. You say we have 143 unicorns or something. You're 1.4 billion people, 143. You need more. It's that ye dil mange more. That needs to happen. And that's how the thinking needs to take place. Tier 2 cities I've already mentioned, and attract and retain women. Please attract and retain women. Pre-COVID or somewhere around COVID, the Indian labor force participation rate of women fell down to 16%, abysmal. Worse than Sri Lanka and Bangladesh. Now it's increased. Now it's somewhere around 27, 28% since I last read. This was my thesis in the Indian School of Business, by the way. So we need to attract them and retain them. I'll give you an example of Tatas in Krishnagiri. So I was speaking with one very, very senior gentleman from Tatas, and he happened to tell me that, sir, there are 70% women in the workforce. Most of them were tribals. Today they're getting education, and they're now not only running their own households, they're entirely running the factory with their prowess. So we need to retain women, and we require industry-sponsored internships for reskilling and getting industry readiness, because there are issues at hand. Finally, she's the caregiver at the end of the day, but then she needs to be absorbed back into the system. So I've already mentioned about the Semiconductor Policy 2021. There's modernization of Semiconductor Laboratory Mohali, which is underway. They're enabling schemes. They're setting up fabs, which are by the JV consortium approach. 5 of them have been given by the Government of India already. 76,000 crores of PLI, or $10 billion. 5 facilities have already been sanctioned by the Government of India. 1 fabrication facility and 4 packaging facilities. And I can tell you, if you go there, the work is in full swing. And it's India. We put our shoulders to the grind, we do it. We will do it. Make no mistake, we will do it. There's an issue of setting up certification and quantification labs, supply chain plugging in dynamics, focus on packaging, all of that. And the last part, and the most important part, is the green process advantage. When all these facilities, which look at 24/7 water, electricity, gases, chemicals, this, that and the other, they impinge a huge carbon footprint on the earth, the most massive carbon footprint. Now when you look at these fabrication facilities, as I mentioned to you earlier, they were all made in the late 90s, early 2000s. There was no concept of the Sustainable Development Goals then. There was no concept of sustainability. There was no concept of ESG. So while India today is a world leader as we speak in renewable energy and various other things, these policies are now going to get dovetailed into these things which we are building from bottoms up. What a great advantage. So that is what I always call it, the green process advantage. And then of course I have to hand over stage to the very erudite Dushyant Sridhar. So I was thinking, how do I link this with Ramayana to make it a little more interesting and give him the pride of place. So there are scientific inspirations, nanostructures. Researchers have drawn inspiration from nature, like lotus, it cleans its own leaf. Self-cleansing properties to develop advanced nanostructures for semiconductor applications. Energy harvesting, natural energy, wind, sun, parallels in the innovations in the semiconductor-based energy harvesting. Material science, again linked towards semiconductors. Symbolic connections, Ram Setu. Ancient bridge represents connection and flow. Like semiconductor devices that facilitate the flow of electrical current seamlessly. Lanka's advanced technology. Same, semiconductors enable cutting edge technology in modern devices. Hanuman's leap. Quantum tunneling. And then you go into the major philosophical parallels. Dharma and design. The Ramayan's emphasis on duty and responsibility echoes that the semiconductor industry's focus on designing ethical, sustainable, and socially responsible technologies. Then you go into the cycle of innovation, the cycle of time. Like in the Western civilization, time is linear. In the Vedic civilization and our own culture, time is circular. So there's a cycle, it is cyclic. The epic cyclic view of the time mirrors the semiconductors industry's rapid innovation cycles. And then of course you have the harmony and balance. I will not go into the Star Wars of Darth Vader and my friend Luke Skywalker. Here, whether you call it Ram or Ravana, I think everything outside which has gone has been taken from us, the dark and the better forces of nature. They reflect semiconductors' design delicate balance between performance, power and management. I am absolutely time on target and I hope I haven't bored you in the last 40 minutes. And I thank you very much for your time, ladies and gentlemen. I hand over to Rishabh.